This is the second part of the homework 2, part 3. Uh, we're trying to add a warehouse loading as well. So what we're trying to do, instead of a cross dock, we need to do a warehouse. Portion. To add that portion in here, we need to slightly do some changing, some decision now on how many parts are going to go to warehouse, how many parts are going to go to cross dock. Okay, so here we have a time path going over here. Let's call this time path about, let's do a 5 minutes. What is the time path? Okay. Oh, okay. This time path doesn't matter then. Okay. And then I have two time paths. One goes to the cross dock. One goes to the warehouse. Also, the returning truck also have a chance going back to the warehouse. Assume this transportation time is about, based on homework, it's kind of random, based on per distribution, with 15 minutes, 20 minutes, and 25 minutes. And on the other one, we go to warehouse. So again, per distribution, with 10 minutes to 12 minutes to 14 minutes, so to speak. Oops, sorry. 10 minutes, 12 minutes, 14 minutes. Now is the question, how many of the unloaded refrigerator go into the warehouse, how many go into the cross dock? As this problem stated, if no trucks parking in the cross dock section, at least 8 of them has to come over this way and rest of them going. If there is a truck parking in the cross dock, then whatever number of a delivered truck already parked here times 8 plus another 8. So, and which means every time you have at least one truckload come into the cross dock, and whatever truck already parked here, we want to fill that as well because they can be immediately shipped out. So we need to define a space that cross dock are going to have. This is the time we're using a function and to talk about this. I'm going to call a function, which is a decision how many parts come in this way. Define a function, call the function, and this function's name, I'm going to call this crossdock space. Okay, if crossdock space is available, then all the parts are going to ship to crossdock. If crossdock space is less than 0, then we're going to forward to the rest to warehouse. As this part is a little bit complicated, so I want to write on here. The space of the crossdock equals to the delivered truck size, okay, and times at least 1 plus how many trucks we have parked in the crossdock parent nodes. So gonna combine crosstalk, input buffer, or parent, I think. Parent no input buffer, and number of content and number of weighting. So this means if the crosstalk has number of truck weighting plus one more load and times the truck load size. Also, we want to minus already the parts already en route to the crosstalk. We want to subtract those out. So we do is crosstalk from the member portion. And number of already travel on that link, and totally how many wrote it in, plus the parts already waiting in the member portion, plus the refrigerator already waiting in the queue. Okay, so member input buffer, content, and number of waiting. Okay, so let's review this again. So number of parts going to forwarded to crosstalk portion is whatever number of truck currently waiting in the parent input buffer plus one more truckload times the truckload size, and minus how many parts already en route to the crosstalk station, minus also number of parts already waiting in the queue to be loaded. So this is how we define this function. Once the function is defined, and pretty much this whole process is done. So all we have to do is on the path portion, I specify the link weight, say function crosstalk space is greater than 0. Okay. Then I'm going this way. If the otherwise, we call that function of crosstalk space is less than or equals to 0, then based on that, I'm going to use this transfer node. I'm going to use, instead of the shortest path, I'm going to base on the link weight. Okay, so if there is a space available, I prefer to put it into crosstalk. And if the space is not available, I forward them to warehouse. What is defining the space available? Meaning it is number of truck already parked here plus one more truckload times 8, and 8 is the truckload size, and minus whatever already travel on this road, and whatever how many ever already waiting in the queue. So that's the available. So you can have a dynamic decision based on that for each individual. And also this transfer node is when the truck coming back from this route, which is, for example, every time simulating the delivered truck coming back each time, we need to determine the trucks are going to go to warehouse to pick up or going to the crosstalk to pick up. So here we were trying to say if there is something waiting in the queue, then of course I want the truck to pick up on the crosstalk first. So this decision is using the similar way of that. Using the time path 8, travel time, double check if there's anything we need. Oh, okay. So we just need to change the way. So in this case, we're just trying to see if the crosstalk section, their member input buffer content has anything waiting. Okay, if some of them are waiting, then I should go that route. I'm going to copy this real quick and paste to this portion, that path. And I said if it's less than or equals to 0, meaning nobody is waiting in the crosstalk, then I send it to warehouse. Again, this one, this transfer no 1 is based on link weight. Of course, we need to direct the output of the warehouse go to dropout portion. Let's just put it into 2 minutes and 5 minutes to show some transportation. Put in 15 minutes now. That's good. Let's see if this runs. I'm going to save this as test 2 portion. You see the parts actually start separate to route, and starting truck is first pick up in the crossdock. If the crossdock becomes empty, the truck going through the warehouse to pick up until next time. This pretty much conclude this major part of this homework this part 3 homework assignment, and I think you can fit in the rest of the detail for finishing up the homework. Okay, that's my hint.